Good morning, everyone. This video is about how to calculate field capacity and forces acting on tillage tool. So first we have to know what is theoretical field capacity and effective field capacity. So theoretical field capacity is the rate of field coverage of an implement based on 100% of time at the rated speed and covering 100% of its rated width. Theoretical field capacity in hectare per hour is equal to width into speed into 36 divided by 10,000. Effective field capacity. It is the actual coverage of machine based on the total field time. Effective field capacity is usually expressed as hectares per hour. Effective field capacity or actual field capacity is calculated as field effective field capacity equal to speed of travel in kilometer per hour into theoretical width of cut of a machine in meters into efficient field efficient in percentage divided by 10 into 100. So next, soil inversion. Soil inversion can be calculated as number of weeds on the surface after ploughing in same area divided by number of weeds on surface before ploughing into 100. Field efficiency. It is the ratio of effective field capacity and theoretical field capacity expressed in percent. So this is a small problem based on field efficiency. A 5 into 20 centimeter double action disc harrow is operated by a tractor having a speed of 5 km per hour. Calculate the actual field capacity assuming the field efficiency of 80%. So in this, width of the disc harrow is given as 5 into 20, so it is 100 centimeter. When we convert it to meters, it is 1 meter. Next, speed is given as 5 km per hour and field efficiency as 80%. So while we apply this given data in the effective field capacity formula, S into W into E divided by 10 into 100, we will get the area of coverage as 0.4 hectare per hour. Next, forces acting on tillage tool. A tillage tool moving through the soil is subjected to the following forces: force of gravity acting upon the implement, soil reaction force, which includes useful soil forces and parasitic soil forces. Useful soil forces are those which the tools overcomes in cutting, breaking and moving the soil, whereas the parasitic forces including friction and rolling resistance are those acting upon the stabilizing surface such as landslide. Forces exerted by the prey mover. If torque from rotary power transmission is not involved, the resistance of these forces is the pull of the power unit upon the implement. These forces must be in equilibrium for satisfactory operation of the implement. First, F, force exerted by the power unit, which can have components in all major phases and associated with its couple. P, pull exerted by the power unit has component in all three major planes associated with its couple. Next is resistance. Resistant are of all useful forces acting upon the tool or implement. Let us resolve the forces in three components: L, S and V. L is horizontal component, also called as draft. V is the vertical component. It removes load from the front wheel of the tractor and affects on tractive ability of the tractor, stability and steerability. It helps in penetration and maintain working depth. S is side draft or force, maintains directional stability. Theta is the angle of inclination of force F in the transverse plane with horizontal. Sin theta is equal to V by R. V is equal to R sin theta. Let's take this as equation 1. Cos theta is equal to L by R. So L is equal to R cos theta, and take this as equation 2. From full definition, D is equal to P cos pi. Therefore, R is equal to F cos pi. This is equation 3. Put equation 3 in equation 1 and 2. So you will get V is equal to F cos pi sin theta, L is equal to F cos pi cos theta. In case of mounted implement, semi-mounted and trailed by tractor, the force P between the implement and tractor in the vertical plane is the force containing L and V component, which is given by the relation P square is equal to L square plus V square. So P is equal to F cos pi. So this is the end of this video, and in this video I have learned about the forces acting on the tillage implements. Thank you.